Hi guys, how you going? Roddy from barberco.com.au. Thanks for tuning in again. Today I want to take a little look at electromagnetic clippers. And for the purpose of this demonstration, I have an assortment of clippers that we use every day in the barbershop. And what I want to do is take the lid off each, compare the motors, and sort of try and impart my knowledge of how electromagnets work and how that translates into an electric clipper. So we have the icon clipper, the super taper, the balding, and the Sterling 4. All electromagnetic clippers, variations of power is the only thing that differentiates them. The icon clipper on the far left has a V9000 motor. The Sterling 4 on the far right is a shunt motor. And the super taper is the oldest of the four here, and it is obviously electromagnetic as long with the balding. So let's take a little look inside each one. I've unscrewed them all for ease. So we'll just take a little look, first of all, at the Sterling 4. And I'll basically explain my knowledge of electromagnets, and they will flow through to all four clippers. So we have the switch trigger assembly on the left hand side here, which is attached to the brass contacts, and when it's switched on, it sends a current up through here to the coil. Now the coil is a whole bunch of copper wires spooled around a plastic spool to create that current that will then generate a magnetic field around the coil. The shunt arm, or the vibrating arm, comes along. When this is switched on, there is a magnetic field around the coil, and because the vibrating arm has springs mounted on either side, which there's a spring in here, and then there's a spring in behind this other side, creates that vibrating repetitive motion that drives the blade. So if you remember back in the old days when we had the old school hand clippers, it was all about repetition of the arm, of the wrist, up and down, up and down, up and down the hair. And all the old guys will tell you how back in the day when they got their hair cut by the old school hand clippers, it used to nip and pull because whoever the barber or your father was at the time wasn't getting that consistent repetition of closing and opening and closing and opening of the blade. This is an electric version of that very same principle. So when the current flows through the coil, sending the vibrating, creating the magnetic field, and sending making the vibrating arm vibrate constantly at, some of them do maybe, not quite sure exactly what they you wouldn't call them revolutions per minute, but I suppose strokes per minute. That does that, copies that motion of opening and closing, but in an electric version up here, and send the blades back and forth, and thus cutting the hair. So it's really interesting, and it's such a simple design, and yet so effective. It's fantastic. So that's the Sterling 4. Now, on the side of the coil, you'll notice a I suppose it's about a centimeter wide piece of metal, which is the magnet that is attracted to the vibrating arm when turned on. Now, the difference between an electromagnet and a permanent magnet is that an electromagnet is created when a current flows through it, whereas a permanent magnet is permanently a magnet. So you might find that electromagnetic principles are used in junkyards, for example, picking up a car, moving it from point A to point B, where an electromagnet would come into place to attract the car to the magnet, lift it up, and hike it over to the part of the yard. So the same principle, when switched on, the electromagnet comes into play, but then when switched off, the magnetism stops. So the difference between this Stirling 4 is there are numerous differences with this, and for example, the old school super taper from back in the day, as discussed, a sizable piece of metal at the side of the coil, whereas there is metal on the side of the coil there, which is kind of hard to see, but doesn't protrude from the coil nearly as much as the Stirling 4. And we know that to increase power or to increase current in an electromagnet, do two things. You can wrap more copper wire around a coil to generate a greater current through it, but you can also have iron going down through the guts of the coil, which will also generate more power. So in this example here, we seem to have more metal attracting this magnet than there in the super taper. Very hard to say about this, discuss the sort of the size of the coil. The sizes of the coil do seem the same, but it is possible that the Stirling 4 has more copper wire wrapped around the spool than this one. And if that's the case, that would generate more power just due to that principle. Keeping the Stirling 4 in hand and taking the latest released clipper in Australia, the Wahl Icon, immediately the coil looks different. It's just insulated by this sort of covering that's wrapped around the copper wires underneath. But if you look at the side, and it's kind of hard to see unless you've actually got the clip in front of you, but the Stirling 4 has that chunk of metal coming at the side. The Wahl Icon has a hole underneath that plastic. Where my finger is, it's plastic. Underneath that is that whole length of plastic is actually a metal bar, which attracts to the vibrating arm in the same principle as the Stirling 4. But there does seem to be more metal there, and if that's the case, that's probably generating stronger magnetism and creating a greater magnetic force around the coil, which is possibly then making the vibrating arm vibrate much faster, which is translating into more efficient cutting in the blade. So this is what is called a V9000 motor, and if you notice at the top of the vibrating arm, which meets into the coil, there's like a sort of a notch there which kind of locks into place a little bit more efficiently, possibly more efficiently than the Stirling 4. Might be conducting greater magnetism through that sort of style, but not really sure what difference it really does make, to be honest. That's the super taper there, which has no notch at all. So whether that makes it less efficient as a result, I'm not sure. It's maybe it's just a stalling, but I don't know why they would do that. It possibly could be just a stalling, just to differentiate the vibrating arms between all the clippers. And maybe the only difference in all of the clippers is both the coil and the metal that sort of comes out of the coil and attracts to the vibrating arm. That would be my take on that. So, but definitely at the heart of all electromagnets is the coil and that magnetic field that is generated around the coil. So look, it's quite possible that this little notch here is irrelevant. Could be aesthetic, and I'm not really sure what difference would that makes, electrically, but certainly the coil and the metal strip at the side of the coil, for when that magnetic force is generated, attracting the vibrating arm, springs in place, vibration, and faster sort of repetition of blade cutting hair smoothly. So that's the 4 clippers that I use consistently in the barber shop. Now this is the Wahl balding clipper, and we'll look at this for quite quickly for a reason, and not so much as to compare the motor. It does appear to be exactly the same as the Sterling 4. I actually can't really see any difference at all between these two clippers. They are pretty much identical. The only difference with the balding is the blade. Now, they're very similar to the fade blade in that the blade is very thin. So, the thinner the blade, the closer it can get. But also, the teeth, there's not much feed through the teeth of the blade. So, the less teeth in the blade, the less hair can get through, which pretty well means that that is just basically going to take the hair right down to the skin. Also, they've been set quite close together, so not quite zero gap. There's about, I don't know, half a mil or something between the bottom blade and the top blade there. But the main difference, as discussed, the Sterling 4 and the balding is the blade. Not much in the way of teeth at all there. If we have a look here at the Sterling 4, look at the difference in the blade. Is the teeth, the feed of hair through the teeth. So if you do a 0 all over someone's head with a Sterling 4 and a 0 all over the head with a Wahl balding, the balding is going to get it so much closer. If you look at the thickness of the blades also, look at the thickness of the Wahl balding blade versus the thickness of the Sterling 4 blade. The Sterling 4 blade is so much thicker. Look at the balding, it's so fine. It's going to get it really close. So, if you want to get a fade blade, you would sort of take an amalgamation of both blades. You would take like the teeth from the Sterling 4 and add it to the thinness of the balding blade, and you would have yourself a fade blade. So that's the differences in the Sterling 4 and the balding. And that is the 4 clippers that I use in my barbershop. And we also sell these clippers on barberco.com.au. Don't forget, guys, to subscribe to the channel and like our videos. It's great feedback for us to know that you're watching what we do and enjoying what we're doing. And it encourages us to put more videos up there for you to watch. So once again, thanks for watching.